Hello everyone. In this lesson, we will learn to compare instruction and the traffic light program. A comparison instruction is used to compare two data of the same type. Comparison instruction is a relational operation, including equal to, not equal to, greater than, less than, greater than or equal to, and less than or equal to. The result is a logical value of true or false. If the comparison is true, the contact is activated and signal can flow through it. If the comparison result is false and the contact cannot be activated and signal cannot flow through it. The symbols and data types of the comparison instructions are shown in the figure. The next step is to learn the traffic light program. At street intersections, in order to ensure traffic order and pedestrian safety, traffic lights are generally installed at each intersection. Among them, a red light indicates that the road is prohibited, a yellow light indicates a warning, and a green light indicates that the road is allowed to pass. Press the start button. The north and south light is red, while the east and west light is green. The north-south red light is on for 25s, and the east-west green light is on for 20s. When the north-south red light is on, after 20s, east-west is green light flashing after 3 seconds extinguished. East-west yellow light and maintain 2s after 2 seconds, east and west is red light, north and south green is light. East and west red light maintain 25s, north and south light is green, and maintain 20s. After 20s, the north-south green light flashes for 3s and then goes out, while the north-south yellow light flashes for 2s. After 2s, the north and south yellow lights out, the north and south red lights, while the east and west red lights out, east and west green lights. The second cycle of action begins. The cycle repeats until the stop button is pressed and all the lights go out. The control time requirements are shown in the table below. According to the above analysis, I/0 distribution table of PLC can be obtained, as shown in the table. Input device is start button, function is start, input relay is I0.0. Input device is stop button, function is stop, input relay is I0.1. Output device address for all lights are Q0.0 Q0.5. The picture is PLC wiring of traffic lights. See the video for details of the installation process. PLC control peripheral wiring of traffic lights. Let's take a look at the final good traffic light PLC control peripheral wiring. Traffic light PLC peripheral wiring. We have to complete the PLC power interface. Input circuit, output circuit wiring. PLC power supply wiring. PLC needs to be connected to the DC 24-volt power supply. PLC L+ connected to the positive terminal of the 24-volt power supply is also connected to the power module plus V. Connect M to the negative pole of the 24-volt power supply, which is connected to the power module V. L and N of the power module are connected to the 220V power supply. PLC and power module need to be grounded. PLC input circuit wiring. Connect 1M of the input circuit to M. Combined with the I/O distribution, start button SB1, stop button SB2 were connected to the PLC's I0.0 to I0.1 and L+ constitute the input circuit. PLC output circuit wiring. PLC 4L+ connected to the positive terminal of the 24-volt power supply. 4M is connected to the negative pole of the 24-volt power supply. Combined with the I/O allocation, the 12 output indicators HL1 HL12 are wired separately. East and west red lights HL1, HL2. East and west green lights HL3, HL4. East-west yellow lights HL5, HL6. North and south red light HL7, HL8. North-south green light HL9, HL10. North and south yellow lights HL11, HL12. One end is connected to PLC Q0.0 to Q0.5, and the other end is connected to 4M. Constitutes the output circuit. In the program, the start button is connected in series with the stop button for output, and the start button needs to be connected in parallel with the normal open contacts of the output relay to form a self-locking. A TON timer is paralleled. Select the appropriate comparison instruction according to tons time to complete the following procedure. Since the configuration has been learned before, the demo is not in the video. In the configuration interface, Devices Networks, find the system and clock memory. Check the box here, and when you are done, choose to enter the main program. After entering the main program, click Normally Open Contact to select I0.0. Click on the Normally Closed Contact to select I0.1. Select the output coil assignment for M10.0. Click on the bus on the left and select the arrow to the right, Open Branch. Select the branch, click on the Normally Open Contact and enter M20.0. Select the up arrow, Close Branch. Afterwards, click on the horizontal line here and select the arrow to the right, Open Branch. Default data block, change the PT value, change the ET variable and enter MD20. On the left-hand side, add Normally Closed Contact, IEC. The option will pop up automatically when IEC is entered. Then select Normally Open Contact, and enter M10.0. Select the comparator operations and enter MD20, enter 25 seconds below and output the assignment Q0.3. After that, we input the following program according to the same operation, because there are more programs this time, so we will not input all of them after the program input interface is shown in the figure. Open the PLC variable table, PLC tags. To change the variable name, change I0.0, 0.1. Q0.3, 0.1, 0.2, 0.0, 0.5, 0.4. Change the name as shown in the figure, return to the main program, main, click on the Compile button, compile. After compilation, if the program has errors, a specific error message will appear. Click on the Start Simulation button and select Program Monitoring, Monitoring on. The green line on the left side indicates on, and the blue line on the right side indicates off. Click Start button. The red light of north and south will be on for 25s, the green light of east and west will be on for 20s, and after 20 seconds, the green light of east and west will be on for 20s. After 20 seconds, the green light of east and west will flash for 3s and then go out. After 20 seconds, the east-west green light flashes for 3s, then goes out. After 2 seconds, the east-west red light comes on and stays on for 25s, the north-south green light comes on and stays on for 20s, and the green light flashes for 3s after 20 seconds. After 20 seconds, the green light flashes for 3s and then goes out. North-south yellow light on for 2s. Finally, let's look at today's exercise. The above content is how to use PLC to control the intersection traffic light, including I/O address distribution, PLC wiring, program design, program input, program simulation verification of learning. Thank you.